Hi, I'm Mr. Lee Chemsir. This video clip is to discuss with you the latest assignment on the topic Introduction to Acids and Alkalis. So let's discuss the questions. Multiple choice question number 1. It is very straightforward that in vinegar, the acid present is ethanoic acid, CH3COOH. Question number 2. An acid that should be stored in brown bottles. It is, of course, nitric acid. Nitric acid, do you know why it should be stored in brown bottles? What will happen if you just store nitric acid in ordinary colorless reagent bottles? What will happen? Actually, nitric acid will be decomposed and the process will be speeded up by light. So, do you know how to write a chemical equation for the reaction involved? Nitric acid HNO3, if it is decomposed, how to write the equation? It will give out H2O, NO2, and O2. Is this equation balanced already? Of course, no. You need to add 4, 2, and 4 here to balance this equation. So by using brown bottles, the decomposition can be slowed down because this decomposition is speeded up by light. So make sure you know. And then question number 3. This question is tricky in the way that you should read carefully the question, the word pure. Pure sulfuric acid here, of course, it means that there is no water. Only the H2SO4 sulfuric acid is present. It is a liquid at room temperature. If there is no water, you should know that the ionization of the acid to give ions will not occur. So, based on this, we need to know that number 2 and number 3 are incorrect statements. Because if there is no water, no ionization, giving out no ions. Therefore, no H+. But if water is present, of course, in this case, the sulfuric acid will ionize. In short, we can write the equation for ionization like this. Of course, if water is present, it is no longer liquid. It should be AQ. Similarly, H+ and sulfate ion all are AQ. Of course, to balance the equation, you have to add the 2 here once again. So only when water is present, there will be the very important ion, that is the H+ AQ. H+ AQ, the ion, is responsible for the properties, the characteristic properties of an acid. So when water is present, that means in statement 1, dissolved in water, it forms hydrogen ions. So it is a correct statement. Going back to the statements 2 and 3, so make sure you know that when there is no water, there will be no ionization. And so no H+ AQ. And therefore the dry blue litmus paper, that means again no water, will not turn red. So this is incorrect. Similarly, as there will be no ions produced, okay, no ions. So the pure sulfuric acid actually should not conduct electricity, okay? So this is again an incorrect statement. So I found some of you were careless, okay? It seems that you did not read the question carefully, okay? So that you made a mistake. So the correct answer is A. Structured question. In the question number 1, you are required to complete this table. First of all, I found most of you perform very well, okay, writing this full chemical equation. And then for the ionic equation, most of you perform very well. Some of you were careless, okay, did not balance the equation here. And also, make sure you know that you must write the formula of CuO. Don't break it down into ions like Cu2 plus or O2 minus. It is because right here, the copper 2 oxide is a solid, okay, solid reactant. And in the solid reactant, the ions in CuO are actually not mobile. Not mobile. So that you have to write the whole formula, CuO. Okay. As for the observations, the copper 2 oxide, the solid reactant dissolves. This is one observation. The other observation, be careful. It is because I found some of your work just putting down the resulting color. Actually, in chemistry, when we are to write observations, if there is a color change, you have to mention the color change. So in this case, from colorless to blue is the second observation. Question number 2. It is a very similar question, just like the question number 1. This time again, solid calcium carbonate is used to react with the very dilute nitric acid. Of course, HNO3. Okay, so the reaction proceeds like this, giving 3 products: salt, water, and carbon dioxide. As for the ionic equation, the idea, just like before, okay, is to be applied again. Since calcium carbonate solid, okay, solid is a solid reactant. The ions are not mobile, so you have to keep the whole formula CaCO3 in the ionic equation. Of course, in these 2 parts, you are also required to write the state symbols. So make sure you include the state symbols in your answers. And then the 2 observations here, I found a common mistake. Most of you could write down colorless gas bubbles as one observation. And then I found many of you write down effervescence occurs. Actually, effervescence occurs. It is somehow meaning the production of gas bubbles. It is not another observation. So if you are asked to write 2 observations, don't forget that as long as the reaction involves a solid reactant, you know, the solid will dissolve. So this is the second observation. So effervescence is not suggested to be written as the observation. Instead, I always recommend you to write colorless gas bubbles. Next question. In question number 2, the requirement is somehow very similar. However, this time, please pay attention to the question. In 2A, one reactant being sodium hydroxide solution. So you all know that by solution, we use AQ to represent its state symbol. Of course, in this case, after you have written the full chemical equation, I think you are, okay, I mean the next step, you are to convert it to an ionic equation. by doing something like this, right? On the left-hand side, you break down the formula of the two reactants, and then on the right-hand side again, for sodium chloride, as it is an ionic compound, you also break down the formula of NaCl like this, and then H2O. And then, of course, you cross out the spectator ions involved, Na plus, and also Cl minus, leaving the ionic equation like this, okay? So this is the correct answer for the ionic equation. And then in part B, it is so interesting that some of you got a wrong ionic equation. First of all, I found a few of you were careless, okay? Right here, you forgot to balance the equation by putting the 2 here. Okay, so this is the correct full chemical equation, and then maybe you start from this to trying to work out the ionic equation. So just like before, maybe you break down the sodium hydrogen carbonate formula like this, and then for the sulfuric acid, as it is a strong acid and also a diabasic acid, on the left-hand side, maybe you write something like this. On the right-hand side, sodium sulfate is an ionic compound, so you break down the formula of sodium sulfate like this, and then giving 2 H2O and 2 CO2, right? Okay, 2 CO2. And then just like before, maybe you, okay, in your next step, try to cross out the spectator ions. So on the left, you found the sodium ions, cross them out. You found also the sulfate ion on the left and on the right. Okay, cross them out. Okay, once you cross out all the spectator ions, what is left? It is an equation like this. And then, did you notice that? Maybe I use another color, okay? Do you notice that at this moment, all the reactants and products will have the stoichiometric coefficients being 2. Then what should you do next? Of course, you have to divide the whole equation by 2 so that you get the final, okay, answer like this. So this is the ionic equation for this reaction. So make sure you know you cannot write the 2, 2, 2, 2 in your answer without simplifying the equation, okay? So be careful. If you make a mistake, don't make the same mistake next time. The last question, question number 3. Oxalic acid, okay? Oxalic acid is actually quite a famous acid in the history of Hong Kong public examination. Oxalic acid, H2C2O4 being the chemical formula, and you are already given the information, its basicity is 2, meaning that it is a diabasic acid. So the first part of the question is somehow, okay, a very important definition for the term basicity. It is the maximum number of hydrogen ions that can be produced by one molecule of the acid. And then in part B, I found that some of you seem to have some difficulty in writing the ionization steps for a diabasic acid. So let me try to use a general principle, okay, to illustrate to you, okay. If it is a diabasic acid, maybe the oxalic acid can be represented by a formula. Make it simple, okay. Instead of writing H2C2O4, why not H2A, okay? So let me show you if a diabasic acid with the formula H2A. How can we write the equation to represent each step of ionization? For simplicity, I don't write the state symbols, okay? All are AQ. And the first equation showing the first step is, of course, to give out the first H+. What is left is you try to do a subtraction, okay? H2A removed, okay, with one H+ removed. So what is left? That should be HA. Of course, don't forget to write the correct charge, okay? After H+ being removed, then you have the HA- as the other resulting ion. Here, you must be very careful. Oxalic acid is a weak acid. The ionization is not complete. So you must write this reversible sign to represent, okay, the change. In case you write an arrow like this, I'm so sorry, this is incorrect, because the oxalic acid is just a weak acid. You really have to know, okay, some acids are strong, some acids are weak. So maybe I tell you later on, okay, which acids are strong, which acids are weak, okay. As for the second step, okay, this is the first step. The second step of the ionization, after you got the HA- as the resulting ion for the ionization first step, okay, then the next ionization step should start with this ion. So let's take a look at these two green boxes, okay. So the second ionization then occurs, okay. Once again, another H+ is being produced. What is left this time? Of course, leaving the A2-. So don't forget that the A is just a general idea. A here is actually representing the C2O4 parts. So if you just replace the A by the C2O4, then you got everything required here. Okay, so this is the way to deal with the problem in this part B. The last part, ionic equation. So please read the question carefully. When I marked your assignment, I found that some of you put down H2C2O4 in the equation. Of course, this is totally wrong because what we want here is an ionic equation. So the answer is as simple as that, okay? Magnesium reacting with H+ to give Mg2+ and H2. Of course, you may start from this, okay, magnesium reacting with the, yes, oxalic acid, H2C2O4, as it is a dibasic acid. In the end, you get a salt, Mg(C2O4), because magnesium ion has the charge Mg2+, and then H2. And then next, you consider the ionization, okay? H2C2O4 will finally become the H+. Of course, there should be 2, and the C2O4-, based on the ionization, just like this one, and this one. Okay, and then on the right-hand side, the salt magnesium oxalate should contain 2 types of mobile ions. One is Mg2+, the other one is C2O4 2-. Okay, once you consider the ions present, then of course you may somehow cross out these 2 first, and then next cross out the spectator ions. Oh, what is left? What is left will be Mg plus 2H+. to give Mg2 plus H2. So it is, okay, once again, the answer here. Okay, I have finished the discussion of all the answers in this assignment. So I hope you got all the concepts and knowledge behind. Okay, make sure you do your corrections. Bye-bye.